Welcome to my YouTube channel. Today we will start with the next part of our Legendre's linear differential equation. In the last video what we have done, we will see that what are Legendre's differential equation and which method you can apply, what is the working method to solve these type of Legendre's differential equation. Now in today's video we will again work on the same thing, but in this case we will solve a problem. Like suppose that you have given a problem 5 plus 2x square d square y by dx square minus 6 5 plus 2x dy by dx plus 8y equal to 0. Now suppose that this equation is given to you, and first of all we can easily say it is a differential equation with variable coefficient, and secondly it is a plus bx type. It simply means that it is Legendre's linear differential equation. Now as I told you, I can solve these type of differential equation. To solve these type of differential equation, first of all we will write down this term in symbolic form. So if we are writing down this term in symbolic form, we will replace our d by dx with a capital D, and here y is taken as a common, equal to 0. Now after writing it, what is the working method of Legendre's linear differential equation? The working method says that we will put 5 plus 2x is equal to 2 into theta, and 5 plus 2, here is d also, 5 plus 2x square d square can be taken by 2 square theta minus 1. So automatically it is 4 times theta into theta minus 1. One thing always remember, that where d is taken as d by dx and theta is taken as d by dz. Again, if d is operator or derivative operator over here, similarly theta is also derivative operator, but that is derivative with respect to dz. So now this is the thing. After that, what we will do, we will put our values in our equation. So if we are putting the values, means we will replace this term by 4 theta minus 1. We will replace this term by 2 theta. Now let's do it. So again what we are doing, suppose the equation is 5 plus 2x square d square minus 6 times 5 plus 2x d plus 8 y equal to 0. As I told you, what we have to do here, we have to replace it by 4 theta minus 1 minus 6. What we have to do here, we have to replace this by 2 theta. So again it is 2 theta plus 8 y, that would be equal to 0. Again it is 4 theta square minus 4 minus 12 theta plus 8, that could be taken, here is again multiply by 4 theta, because 4 theta into theta is 4 theta square, 4 theta into minus 1 is minus 4 theta, y that would be equal to 0. So it is 4 theta square minus 16 theta plus 8, y would be equal to 0. After that what we will do, because it is homogeneous differential equation, as we easily know, if we have homogeneous differential equation, what we have to do, our complete solution is directly given by complementary function. So before writing complementary function, first of all we will write down its auxiliary equation. Now the question arises, what is the meaning of auxiliary equation? Auxiliary equation means that you will take a coefficient of y that would be equal to 0. So in this case we are taking coefficient of y, means 4 theta squared, then here is minus 16 theta plus 8, that would be equal to 0. Now here we will find the value of theta. After finding the value of theta, we will write down the solution. So remember, how can you find? It is uh, our equation which is given to you, quadratic equation is given to us. So how can you solve the quadratic equation? We can usually use determinant method. So this is theta minus b means minus 16 plus minus b square 16 square minus 4 times a and c, that is divided by 2 times a. If somebody don't know, I'll just write it down. If you have equation ax square bx plus c equal to 0 and you have to find a value of p, discriminant says minus b plus minus b square minus 4ac divided by 2a. So same thing we are doing here. The value of a is taken as 4, the value of b is taken here minus 16, and the value of c is taken here as 8. So I just want to rub it to get a place. So now how can we solve further? That is the thing. So always remember, to solve this equation it is 16 plus minus 256 minus 4 is into 16, 16 into 8. If we are multiplying 16 into 8, we are getting 128 and divided by 8. So after this again we are getting here, if I want to solve it, 16 plus minus 256 128, this is again 128 divided by 8. So again if I want to solve it, it is 16. After 16 it is plus minus. If you will easily know that, I can put here it in the form of 8 root 2 divided by 8. After this, what I can do here, 8 is taken as a common. It is 2 plus minus root 2 divided by 8. So we have 2 root, that is root plus 2, sorry, plus 2 plus minus root 2. It means that 2 plus root 2, 2 minus root 2. It has 2 roots are given to us. Now, if we know that we have given a 2 roots, so the value of y can be given as c1 e raised to power c1 e raised to power, what is it, 2, yeah, c1 e raised to power 2 plus root 2. I'll just take it, c1 e raised to power 2 plus root 2, then z, because we are talking about theta, so it means that we will replace it by z. If on the other hand this value is something like in terms of t, so we will use here x. So now after this it is c2 e raised to power 2 minus root 2 against it. So I can easily see, I can write down c e 2z into e root 2z plus c2 e 2z into e minus root 2z. Now e raised to power 2z is taken as common, c1 e root 2z plus c2e minus root 2z. Now we know that we have to replace the value of z. How can we replace the value of z? Again we know that, as the thing is that we will always put 5 plus 2x is equals to e raised to power z. So what is the value of z? Z can be taken as log of 5 plus 2x. So what we will do here, we will replace this thing by e2, that is log of 5 plus 2x. This method is already explained in the last video, that we have to take a plus bx equal to z. Similarly, here in place of a plus bx, we have 5 plus 2x. So we will put that value equal to z. So now again here we will take it is root 2 log of 5 plus 2x, then again it is 5 plus 2x, then again plus c2e minus root 2 log of 5 plus 2x. Now we can solve here, because a log something like a log b, so we will write down log b raised to power a. So similarly here we will take e raised to power log 5 plus 2x squared c1, then e raised to power log of 5 plus 2x root 2, then plus c2 e raised to power log 5 plus 2x minus root 2. So again e and log, we will left only with 5 plus 2x square, that is c1 5 plus 2x root 2, then plus c2 5 plus 2x minus root 2. So this is the solution of our Legendre's polynomial. Thank you very much.